So these are just my respiratory module notes, and so the first note I have is just that oxygen is not diffusion limited. So what does that mean? It just essentially means that if you have your alveolus, right here, and you have a partial pressure of oxygen at 100, and then you have your vessel right here with your venous side and arterial side, well, when it goes along, when the blood's moving along, the oxygen will diffuse through the thin membrane right here and into the capillary and then be oxygenated. And so how fast it does it determines if it's diffusion limited. So as you can see in this graph, on the y-axis you have your capillary O2, just showing how much oxygen the capillary has, and then this is the distance along it, so this would be 0, and then this would be 100. And so when it starts, right, it slowly increases all the way until it's 100 right here, right? So as you can see, there's a while, there's some distance before it gets to the full length of the capillary, so it actually quickly oxygenates, so therefore it's not diffusion limited. All diffusion limited means is, does it get to 100 before this line right here at 100? And so it does, and it does so pretty quickly, and so this is actually useful that it oxygenates this fast right here before it gets to the end. And I can explain that further. So you can imagine it as if there was a train going by, right? There's a train going by, and then you have a bunch of boxes that you need to put on the train. And so as you're putting the boxes, it reaches 100% of the boxes that you need at this distance, right? So by here, you already have all the 100 boxes that you need to put in here. And so that means that it's not diffusion limited because you got to 100 boxes in the capillary before you hit this line, right? And so why is this so important? Why do we need to get it full right here instead of all the way down here? So when you're exercising, the blood's moving way faster, right? And so when you're exercising, it still needs the 100 boxes, but now the blood's moving super fast. The train's moving super fast. But the rate of the people moving the boxes is still the same. But because you have this huge, gradient, right? You have this huge length of time before it gets to 100. That's okay, because even though it'll only fill up by here, when it's exercising, because you're moving so fast, you'll still reach 100 before you reach this line. And so the other factor is when you have diseases, right? So diseases can make this harder, for example, and it can make the people, in the metaphor, move slower. So therefore, in diseases like fibrosis, where it's a thicker wall and it will cause less oxygen to diffuse, this is useful because since it quickly saturates so fast, even if you have a disease, it won't necessarily cause hypoxia because you have all this leeway, and so you have so much more room. So even if there's a defect, you still have time to get to 100 before it hits the 100. And so another thing to go over is the fact that CO, carbon monoxide, is diffusion limited. And so in this case, what happens is you have all the CO, right, carbon monoxide, and so for example, let's say there's 100. Well, the problem here is that when it goes into the capillary, they can only diffuse so much, and on the other hand, when it hits the hemoglobin, right, when carbon monoxide binds, it binds so strongly that it actually only can bind to one hemoglobin, and it prevents anything else from binding. So one carbon monoxide binds to each hemoglobin and prevents anything else from binding. So therefore, it can't reach 100 because it fills up the hemoglobin and it also fills up the capillary, but there's still a greater concentration in the alveolus in regards to the capillary. So in this case, it is diffusion limited because it can't reach 100 in here, because if there's 100 in here, it can't reach 100 in here by this arbitrary mark because it saturates the hemoglobin too fast. So that'll be the first part of this series, and I hope that helped, and thanks for watching.